Okay, so this is part 2 of a tutorial for how to make a capacitive discharge launcher for model rockets. And as I was explaining, the problem is when you dump 350 volts, in this case, this is like 120 joules, that's like 60 joules. When you dump all that through a switch, you get arcing, carbon buildup, and the switch basically ends up toast. I forget how many switches I went through. I would actually, fortunately I had one I could actually take apart and I could clean the carbon out, but that got pretty old pretty quick. So the way a flash tube works is it's basically just a tube with xenon. And the xenon doesn't normally conduct electricity. So you basically have, if you will, 350 volts on this, but this is, as you can see, that's an air gap, or a xenon gap of over half an inch. So there's no electricity going through that. However, what you see on here is a little bit of foil, and that foil connects to essentially the trigger. That's the trigger coil, and that's what this little guy is, by the way. When you press your trigger, when the camera, you take the picture and it wants to trigger the flash, it puts enough power to that coil that you end up with, I think it's like 100,000 volts, just for the briefest of moments, onto this foil, and that causes the xenon inside to become a plasma, which then allows the power to go through. There is a little bit of power loss, and that's what you see in the flash, but that is why you do need more capacitors. I'd suggest at least 4 or 5. This guy has 6, and this will easily do a cluster of, I want to say, at least 5 or 6 solar igniters. I've done the Aerotech copperheads with this, no issues. But what this means is 2 things. One is you connect your rocket leads you break the circuit on this and you connect the rocket leads, and you can see it here. Normally this would be the end of the flash tube. This would just solder to, and this is part of the circuit here. I just found it easier to solder it here. And so when the flash triggers, this connects, and then the power goes from here to your rocket and then back, and that completes the circuit. In this case, and let's see if you can see a little better, I actually separated the flash tube and shrunk wrap a piece of copper wire around it just to make it package. I wanted to make it super, super tiny, as you can see here. This circuit board is a fraction, a third, half or a third the size of this one. And so that allowed me to do that. So you don't need to do that, like I said, with this one, and this one has worked plenty of times perfectly well. Short circuits just from here to here. And actually, this one's a good one to look at for the trigger again. Oh yeah, I think we said this was a slightly different circuit board than the standard. But in this case, as you can see, this green wire here to that green wire there, that is the trigger that for this particular generation of circuit board, which on this one here would be, let's see, yeah, no, too hard, too late at night for me to go trying to trace the circuits. They actually look very similar on this side. This actually might be on one side, might be this guy here, and then this one here. Okay, so that's this trace. Yeah, So it appears to be shorting this to this, if I'm not mistaken. Okay, like I said, you'll want to double check on yours, and there's no polarity on that trigger switch. Okay, one last thing. These originally run on 1.5 volts. Like I said, they run off of just a regular AA. I found no issue with running them on 3 volts. But I think at one point I was running them on 6, and that burned out the transistors. Now this one only has 1 transistor. Some of these other ones have a few more. The ones that had more transistors, like this is an older board. It has 3 transistors. They seem to be a little bit more robust, but either way, I've tried different ones and they all seem to work. Let me just go back to here. So basically, with this, you just need to break the circuit on the end of the xenon tube, and so that connects through the rocket, and that's number 5. Any questions? Go ahead and post them on the comments on the bottom of the video, and I'd be happy to answer them. Thanks for watching.